Okay. Put your phone away. He's like he's like this, yeah. I figured you were. Okay. Guess what we're gonna do the calculus today. Okay, guys? Oh, and by the way, oh, I told you guys, Inspire now has the app out for the iPad. I think I told you. You can. I gotta link it up, but if we get through the cell, I'll have time. Okay, we're doing the calculus today. Before an integral, okay, Casey? Okay, you guys, Jack? With the limits of integration was called a definite integral. We're going to do indefinite integrals. We're going to find antiderivatives. So if I tell you that my derivative of some function is equal to x squared, what did I take the derivative of? The derivative of x squared is 2x. That's equal to 2x. What if I go the other direction? Okay, Zach, what would this be? Well, you could do guess and check. So if it's 1/3 x squared, what if I take how do I know? If I take the derivative of this, I get 2/3 x. I don't get x squared. What is this? Oh, okay. 1/3 x cubed. And Stephen, how do I know it's really the antiderivative? If I take the derivative of that. What if I have the derivative of x cubed over 3 plus 4? What's the derivative of that? X squared. Notice that. Bring the 3 down. 3 over 3 is 1. Notice that the derivative of x cubed is x squared. The derivative of x cubed over 3 plus 4 is also x squared. So what could you do here? No. Well, if I take x cubed over 3, which might look something like this, and what if I add 4 to that? Does the slope of the tangent line change? No. So it doesn't matter where this function is. The slopes there are going to be the same. The slopes there are going to be the same. So this plus 4 doesn't affect the derivative. So if I find the antiderivative, the function could have been shifted in any direction. So we have to add in a constant. It's an arbitrary constant. So we say plus c. But you could do plus g for Golombeski. The constant could be 0. We are not going to know what it is. And it doesn't matter what you call the constant. You can't call it pi, because that's a specific constant. It has to be a letter representing a constant. So we're trying to find antiderivatives here. What's the antiderivative of x cubed? And the way I know it's an antiderivative is to take the derivative. How do you know you factored a trinomial correctly? You FOIL it back out. Okay, we're not using calculators either, Stephen. We will. We do. But remember, most of the exam is without a calculator. They've gone away from the calculators. So now, what do you take the derivative of to get 4x cubed? Just do a guess and check. X to the 4th. Does that work? How do I know? Grace, how do I know? What's the derivative of x to the 4th? 4x to the 3rd. What should be added here? Plus c, because if there's a constant here, what's the derivative of a constant? 0. So maybe at the end we'll play the Bohemian Rhapsody and really talk about the adding c. Don't forget to add c. And it's critical. We'll do it at the end, though. Okay? We can do it at the end today. We should have enough time. Okay. Now, a symbol for, you guys, a symbol for an antiderivative is this. I want the antiderivative of some function, f of x, and we have to tell it what the variable is. Later on in math, if you go on in math, you're going to do multivariable calculus. And you can mix x's, y's, and z's all inside of a function. So you have to tell whoever's doing the antiderivative which letter are we talking about. And also, there's a geometric reason. So it's going to bother some of you. You're going to come back tomorrow and say, well, what do I do with that dx? This is with this is the symbol, meaning find the antiderivative. And antiderivative, actually. And we're going to list them all that we're going to need for this assignment. Because as I looked in the book, I go, oh, I guess we need some more. Yes. That is the new symbol for Riemann sums, but there's no a's and b's. So these are called indefinite integrals. And we will find the connection soon. There is a connection there. Right now, we're taking this symbol without the a and b to mean an antiderivative. Okay, different meaning. Is that okay? So we need to find antiderivatives of different functions. And you had a sheet that had functions on it and had all the derivatives. You filled that out. And at the bottom of the sheet were a bunch of functions. You find the antiderivatives. These are the only ones we know how to antidifferentiate. Okay, Jack? So what's the antiderivative of x to the n? Now this symbol with the dx means find the antiderivative of that. And maybe I need to go to some concrete examples first. Or can you see it already? What's the antiderivative of x? 1/2 of x squared plus c. What about the antiderivative of x squared? 1/3 x cubed plus c. Where did the 1/3 come from? Because when you differentiate x cubed, you're going to have a 3 there. Do I want the 3? No. Let's do some more. What about x cubed? Well, it's x to the 4th. But if I take the derivative of x to the 4th, I get 4x cubed. I don't want that. Patterns, and this is mathematics. When you start looking at patterns, and the ahas I hear. What about x to the 4th? 1/5 x to the 5th plus c. Now, do you want me to, okay, what about, why is it what? Because how do you know this is an antiderivative? Take the derivative. So if I don't have the 1/5 there, I'm going to have 5x to the 4th. But I don't have that. Now, an antiderivative and a derivative are inverse operations. They undo each other. So what if I take the antiderivative of a derivative? No, not one. I get the function back again. It's an inverse. That was an important one to know. Well, I want to do two more. We're still on the ivory one. I'm just doing things to help you see things. What about the antiderivative of 1 with respect to x? That's just x. I'm going to put another list over here. And the reason why we're going to do this is so that you can do the homework. Because I looked at it and I go, oh, yeah, you got to remember these other ones. Otherwise, you'll get stuck. What has to be added here? Okay. Let's go the other way. What about negative exponents? What about x to the negative 3? I could do negative exponents. Okay, Samuel? What's this going to be? How are these exponents? Well, let's get the rule. What's happening to my exponents? Then we'll come back and do the negative. So what's the antiderivative of x to the n? It's x to the what? N plus 1 divided by n plus 1 plus c. Now, the problem with the negative exponents is that we kind of mess up once in a while. I tend to go the wrong direction. We're going to add 1. So what's that going to be? Negative 2 over negative 2 plus c. So you could have negative 1/2. What about x to the negative 2? x to the negative 1 over negative 1 plus c. And I always write it that way, and then I'll clean it up later. Okay, Samuel? Pick up. What about this one? If you use our rule, what would this be? It would be x to the what? 0 over what? 0. Well, it doesn't matter. X to the 0 over 0 doesn't make sense, does it? That doesn't exist. But do we have a function that if we take the derivative of it, we get x to the negative 1? Let me write it in a little different way. Why don't we write it this way? What's the derivative of what is 1 over x? That's right. Natural log. Natural log of x. Now, I'm not going to explain why we're going to put an absolute value at the moment, but we will be putting an absolute value plus c. We can't forget that absolute value. It's critical. Okay, so the power rule works every place except when the power is a negative 1. The power is negative 2, no problem. It has to be a negative 1. We are not doing composite functions. Not yet. So let's put this in our list. So the antiderivative of 1 over x is the natural log. It doesn't fit in my pattern. Oh, well. Wait a minute. Now, there's some other ones. How about trig? What's the antiderivative of the sine of x? You are right on it today. Negative cosine of x plus c. How do I know I did it right? Take the derivative. I'm going to say that a million times before the end of this chapter. Probably end of the year. Well, a million might be a little exaggerated. What's the antiderivative of cosine of x? Is it negative sine or positive sine? It's positive sine of x. Okay. All that list that you've got on the top part of that sheet you have to know. Not with the composite ones. Do you remember this one? The derivative of what is secant squared? Tangent. What? You don't like those? We are going to figure out. These are the ones, when you see them like this, will work. If they don't work, if they don't look like this, then we're going to have to work at making them look like this. And that's later on. I think that's in chapter 6. So we don't have to worry about this yet. These are just straight antiderivatives. Do you know this one? Secant of x, tangent of x. Derivative of what is secant tangent? Not secant squared. Just the secant. What's the derivative of secant? Secant tangent. So we could do the other ones. You can look them up, yes. And what about, there's some other crazy ones. Okay. Okay, let's do two more, and I know they're in the assignment. So if you have this written down in front of you, or you can print the PDF. I didn't get the videos up yesterday, but I did get the PDFs up. I just forgot to do it. 1 over 1 plus x squared dx. Does anybody remember that one? No? Inverse tangent. Yeah, you did. Well, knowing that, what's this one? Inverse sine. You could do inverse cosine, but you'd have to put a negative. So there's identities, which you haven't studied, that put the trig functions together, that connect them. The inverse cosine, since you're asking, is with a negative sign. So if I have negative 1 over this, but it doesn't matter, they're both right. is equal to inverse cosine. So these are related. Their derivatives are just the opposites of each other. And I know not everybody was in my class last semester, but the derivative of all the cofunctions are negative. Come here, give it to me. It's almost like a game, isn't it? Okay. So the trick is to do antiderivatives is to make everything, you guys, to make everything look like these functions right here. You have a power, n can be a negative number. N belongs to the reals. N could be pi for that matter. Let's do that. What if I have the antiderivative of x to the pi? Because they do that in this book. So you go x to the what? What do you do with the exponent? Raise it up by 1. Well, that's pi plus 1 divided by pi plus 1. That's it. So it doesn't matter what n is. It can be a negative number. It can be irrational number. It doesn't matter. No imaginaries, though. Now we can try some problems. So if you get these all written down, you're in great shape. I don't remember what color she was, and the answer key is up online, but it's the integrals and the derivatives of all the functions. Yes, and you should fill it out and make sure you memorize it. Okay. Let's do the examples. There aren't very many, and then you have time to ask me questions. Yeah, oh, absolutely. Absolutely. Yeah, because they're all related, aren't they? These are just inverse operations. I don't think we understand inverses, but that's okay. Okay, I did all those, so let's just start. Now, one of the things that you need to realize is if you have the integral of some k times f of x dx, you can pull the k out. Another thing, if you have the integral of f plus g, you can integrate them separately. Now, you won't write it separate, you'll just do it. Does that make sense? Casey? No, we don't do that. Okay, Colin, what's the antiderivative here? Now, we can call it capital F of x, or we could use that integral sign. Okay, what's the antiderivative of 3x squared? Some of you will see it, some of you won't. Casey, what is it? Casey. What's the antiderivative of that? We'll take a guess. You want to say it's x cubed. Is the derivative of x cubed 3x squared? Good. Well, no, we're not done. We'll put one big constant at the end. It's 10 what? X to the what? Second over 2. Plus 7x. Now we have plus what? Let's see. They're never going to be this easy. How about the next one? Remember, all we have is x to the n. It's certainly not a sine or cosine. It certainly doesn't look like an inverse trig or anything. So what about x to the n? We can maybe get it to look like that. Anybody have some ideas? Negative. Right, write these as negative exponents. X to the what? No, that's a 7. Negative 7. So what's my antiderivative? Now, is it easy to go the wrong direction? Yes. I still do it, and I've been doing this a long time. So it's x to the what? Zach, what is this? Go up 1. Over. There's 2. Is this easy? As long as it's the power rule. As long as we don't have composite functions. Casey's doing the next one. 6x to the what? Negative 6 over negative 6 plus c. If it's free response, I don't care if you simplify. And for this assignment, I don't care if you simplify. But you'll have to go to the solutions to check your answers in if you don't simplify. Okay? Just a few more examples. Ready? I need to have number 3 look like x to the n, and it doesn't. Anybody got an idea what I can do to fix that? I don't. By the way, I don't have a product rule or quotient rule on antiderivatives. Negative 5 then. You can. I wrote it a little differently. Are you ready? I prefer to just plain divide, but some people will do this. So little f of x is equal to x to the negative 5th times this. It depends on your learning style. You can do that, because that's what that means. Or you can just divide it. So f of x, and if I divide, x to the 5th must go into each term. It's distributive property. So it's 4x to the 6th over x to the 5th plus 3x to the 5th over x to the 5th minus 8 over x to the 5th. I don't care. You're going to get the same result. Which way do you like it? The first way? Okay. So what do you do with exponents here? When you're adding them. So that's going to give me 4 what? X. I think this is easier. I got 5 here, 6 there. I got 4x. That's me. Colin, what's next? Plus 3. And then you add x to the negative 5. Plus 5 is 0. I think this is easier, and this just gives you 1. So I'm just going to get that, and then I'm going to get this one, minus 8x to the negative 5th. And then we can find our antiderivative. Is that okay? Yeah, just tell me when it's not. It's not a problem. Sometimes I just forget and just keep moving. Okay. Colin, can you give me the antiderivative of 4x? Well, it's going to be 4x, and you're going to go up 1 to the left. This always works. Up 1. 2 divided by that exponent, which is 2. Some of you will see right away it's 2x squared because you just see it. Others, you're going to write it like that, and then you'll see it. It doesn't matter. What's this one going to give you? Plus 3, because this is really x to the 0. So it's x to the first over 1, if you want me to be particular about it. Minus 8x. I want to go negative 6. I've been wanting to do that all hour. No, it's going up. Negative 4 over negative 4. Yeah. Because my goal is for you to understand how to do an antiderivative, not simplifying that. But you're going to have to check your answers online. See, somebody said something about the chain rule for number 4. Yes, I have a composite function. How are we going to deal with the chain rule? Well, we don't have to deal with the chain rule. Not yet. Can't you what? No. Somebody said FOIL. You can multiply this out. Oh, well, let's see. All right, that's a y squared. Y squared plus 4y. The problem is if you try to integrate that, some of you are going to say, well, then I just get this. Y squared plus 4y cubed over 3, right? But does that work? Because of the chain rule. The 3's will cancel, and you still have to times it by the derivative of the inside thing. Then some of you try to divide by the derivative of the inside thing, which would be 2y plus 4. And now things have really gotten ugly. Differentiate this. What will this be nice and simple, like y squared plus 4y quantity squared? No, it's a quotient rule. I will see that on the test. I know I will, because I always have. Never do we do anything this complicated. Never is going to be like that. So we can't do that. The only way to do it is to expand it. That's the only way to do this problem. Okay, so we're going to multiply that out. So it's the integral of y to the what? Fourth. And honestly, when I square binomials, and I know the trick to doing it, I still write it out. This is going to give you 4y cubed and another 4y cubed, which is 8y cubed. It's so easy to mess it up, but anyway. And it's plus 16y squared. Okay. Do you see why I did dy here? I didn't mean to do it. I meant to ask you. These variables have to match. And when you get into upper level calculus, multivariable calculus, you will see more variables, and you're going to have a dx and a dy and a dz in the problem. Yeah. Well, it's really not that bad. If you don't know the basic calculus, it just goes right into it naturally. Okay, so what's the antiderivative of y to the fourth? Colin, can you help me with that one? All you do is add 1 to your exponent. Y to the what? Add 1. Yep, that's right. That's right. Beautiful. Casey, what's the next one? Can you see? It's 8y cubed, so we're going to go up 1 over 4 plus 16y over 3 plus, see, what's the question? What was the question? 8y cubed, because it's 4y times y squared. You have to FOIL it. Although, based on our algebra quiz, some of you still don't want to FOIL. Do that. That's it. How do you know what? Yeah. You had that question, somebody else does. I'm just not thinking. Because this little symbol here, this symbol, the integral symbol with the dy, means find the antiderivative. The derivative of what would give me this? So every function is a derivative of some function. Yeah. Huh? Because they gave it to us. This symbol with the dx, dy, dz, it doesn't matter what it is. Find the derivative of whatever that is with respect to z. So if I had a 2 dz, what would that answer be? It's 2z. This just identifies your variable. It doesn't do anything. It just says the letter that we're working with is z. Does that make sense? I didn't make up this notation. Leibniz did, and this was at the birth of our country. So this is going on over in Europe. We didn't have mathematicians over here quite at that time. In the 1600s? I don't think so. Yes, we're going to do that one next. Okay, let's do this one. We have a short quiz tomorrow. It's an AP question. You have an AP packet. Answers are online. What should I do with that 3 to make my life a little easier? No, it's 5-1 and 5-2, which is Riemann sums, Goldensky sums, rectangles. No trapezoids, just rectangles. Rectangles are easy. And just find the area of the rectangles, base and height. Did you do 5-1 homework? Let's do 5-1 homework. And we did an AP problem. You could study that too. And so I was helping one of my algebra students with her physics today, and they were asking for average speed. What's average velocity? Change in what? Position over the change in time. I said, you're doing what we're doing in calculus. Yeah. Average rate of change. Okay. Let's integrate this. This is x. Now I got to take the 2/3 and add 1. See what's 5/3? It's 2/3. Well, a variety of ways to do it. Plus 3/3, which is 5/3, and then we will do what? Divide by 5/3. I don't like the way that looks. Do you? Well, it's right, but I won't be able to match on the AP exam. So how can I get rid of 5/3 here? Multiply by 3/5. So what's the answer going to be when I multiply that? Okay, so 3 times 3 is 9, and 5 times 1 is 5. X to the 5/3 plus C. Can you always check these? Yeah. Now, how am I going to do this the fast way? I don't want to do this. This is too much work. When I divided by 5/3, in effect, I ended up what? Multiplying by 3/5. It's inverse, yes. Two things we're doing there. And that's all there is, except I did forget one integral. I don't think it's in the assignment, but we might as well do it. What's the antiderivative of, this is the toughest one of all, e to the x? It's e to the x plus c. Right? Like a phoenix coming out of the ashes. The derivative of e to the x is the same thing back again. Oh, I talked about it. Hers one does it better. It's our old calc book. It's just like a phoenix rising out of the ashes. Okay. Do you have any homework questions you want to ask me? How can you prepare yourself? Go back and look at your homework and do some problems again. That's a very good question.
I did do my homework.
Huh? Now, I can come around and get 5-1 and 5-2 marked off. If it's not marked off, I have it on my iPad, and I just come around and do it. Oh, look at this. Yes.
No, I was going to ask
Not
you.
now. Not now.
No, I was going to see if it's
You
in.
were playing a game.
No, I was going to ask you. I was looking to see if you had it.
He was looking at grades and stuff.
No, that's not. No, the thing is, I was going to tell you my
Pretty soon I'm going to make a lot of money. No, just kidding. Do you guys have questions on homework? Anything out of 5-1, 5-2. Okay, shh. 5-3, I don't care. Shh. 5-3. I might need to get it from you. Which one? 11. And this is time for you to work, not play games or sleep. That's tomorrow. Yes. And if you don't ask me questions, I still don't believe you're doing your homework. I want the average value of the function on the interval. And where does it assume the average value? Do you remember the formula? F of c average, I'm going to add up all the y values, f of x, dx, which tells me you didn't start your homework, from a to b. And that's going to add up all the y values, but I want to get it. Remember how we average? We divide by how many values we have. So in terms of calculus, this will be divided by b minus a, the width of the interval. I can go ahead and show you again why it is what it is. But right now, you just need to know this. So we're going to use a graphing calculator to do it. That's the NNIT, INT, whatever they call it. So it's x squared minus 1, but that's a good question. Sometimes the directions that are given in this book are kind of like, what are they asking? Even I wonder. 0 to the square root of 3 divided by the square root of 3. Now, the biggest problem when you get to a calculator problem like this on the exam is you write it out this way, but when you get to your final answer, guess what you forgot to do? You forgot to divide by the square root of 3. I don't know. I don't have my phone out. For what? Where's your pen? Yes, they do.
They do? Well, can I go get a pass?
It's so funny. Okay, you're almost as funny as my doggy. They are funny. Okay, let's clear that out. And I'm just going to integrate that, so it's math. I think I might be in pretty print. Oh, no, I'm not. That's good. So, x squared minus 1. X comma what? 0 comma, okay, square root of 3. Okay, you guys. Okay, did I have it typed in right?
I think so.
So 0?
Whoa, that's a really small number.
And then you're going to do, what do you have to do with this? Divide it by the square root of 3. I don't feel like that's right.
That's going to get very small.
Can I take this?
weird. Something's not right. Um,
Plug in.
that's the answer. So let's check, because I know how to do it. You will too, by the way, know how to do that. So it's the square root of 3 cubed divided by 3 minus the square root of 3. Now, if I were on an Inspire, I'd get the exact answer. There's the exact answer. It is 0. Well, 10 to the negative whatever it was, 10 to the negative 14 is almost 0. Yeah, so this ends up being 0.
You plug this in.
Want me to show you algebraically?
This now.
It's the square root of 3 squared times the square root of 3. Now that I look at this, this is 3 square root of 3 over 3 minus the square root of 3. 0. But you don't know why I did this. But that's coming. That's coming next week. That answer is correct. So that's the final answer if you use your calculator. That's the problem with the calculator. That's why the math, the algebra itself came in handy for me, didn't it? Because I go, that doesn't feel right. Okay, other questions? And now I'll bring up the textbook, and you can work on these problems, because a lot of you are not bringing your book. This book is online, and it has the answers in there. So there are some problems here. Now, this is 5-2. So I don't know if you have any questions. Yes. Why can't you do that? That must be 5-3. Yeah. Yeah, that's 5-3. I'm going to say we haven't done that. So if you want to start the assignment on 5-3 or work on it, there it is. We don't know how to do some of these things. We will. I'm a little too far. You certainly can do these. Which ones? Oh, I can do those. Can we do this on the board? Okay. Which problem number? This is the algebra. Which one? Number 2? Okay, this is the new one. Practice sheet. And I want f of h, x plus h, minus f of x over h. So f of x plus h, I'm going to put in x plus h in for that. So it's going to be 1 over x plus h plus 2 minus 1 over x plus 2 all over h. And I don't like complex fractions. Do you guys like them? No, it's too hard. Multiply by the common denominator. When in doubt, multiply them out. Multiply them together. Now, you guys, why did I choose that? Well, this has to be equal to 1. So these have to be the same. But why did I choose that?
So the middle ones cancel.
Not the middle ones cancel, but when I distribute, this will cancel with this, and I'll be left with x plus 2. Now, I'm going to be safe and put in parentheses, because I like to get the answers right. This one, the x plus 2 will cancel, and I'm left with x plus h. All over this thing. The only thing I can think of is to go ahead and simplify that numerator. So I get x plus 2 minus x, here's where the mistake is, minus h minus 2. And I promised you, those of you who had me first semester know this, that everything is going to cancel out. Or just about everything. Because if it doesn't, I'm in trouble. Okay, what cancels here? The x's go, the 2's go, and I'm left with a minus h. over h, x plus h plus 2, x plus 2. Yeah. I don't want to distribute. I want to cancel. So it's negative 1 over this. This is the average rate of change. It has an h in it. You could change how far you go away from that point and have a little formula to figure out what the average rate of change is. If I want the instantaneous, I'll take the limit. Oh, wait, we got a lot of time. More questions? Yeah. About 5, 2. Oh, what are we going to do with this one? First thing you always do is substitute. Okay, guys? How about this one? Everybody can benefit from this. There isn't anybody here who can't. Jacob, what do I have to do with that one? I still get 0 over 0. This is it's just a trick. Why don't we multiply by the conjugate? Because when I FOIL that out, the square roots are gone in the numerator. But don't multiply that out in the denominator. Leave it as a product. The limit as x goes to 4. I don't know. You notice my vocabulary? Have you heard this much vocabulary before? So this is x minus 2 over x, sorry, it's not x minus 2, it's x minus what? 4. X minus 4, square root of x plus 2.
And they cancel out.
Because it's a multiplication problem. So it's equal to the limit as x approaches 4 of 1 over the square root of x plus 2. Now, I can go ahead and put 4 in because I didn't care what happened. But if I'm close to 4, I get this. That's right. Which section? Now, as an example 4, there's a lot of stuff in here. Where's example 4? Trying to find example 4. I know what the answer is. Oh. I just don't like that. We can't do that yet. Tomorrow we can. Is it an assignment for today? Well, it does? Really? Oops. Number 19, this is off the assignment. We know this is 2. Okay, guys. And 19, I want to integrate from pi to 2 pi. Let's just do this geometrically. Okay, girls? The integral from 0 to pi is 2. That's 2. If I go from pi to 2 pi, it's below the axis, so the area, this actual area is 2, but the integral is negative 2. This I know from example 4. We don't know how to do it yet. You could put it on your calculator and do FNINT. Yeah, tomorrow we would do it. It has to go from smaller to larger. Yeah, because it's the same, isn't it? But I couldn't do it without looking at the picture. Jacob. If you do this symmetrically, and either you do it this one, that's 0. Full cycle, the integral is 0, but what if you just take this from here to here? It's also 0. This is an odd function. Remember odd functions? And then it's periodic. So yes, the periodic ones. So cosine will give you some zeros too. Whoops. Tangent's odd. You'll draw some pictures. You'll see it. It depends on what you